the review session. I'm also recording this as well. All right. So first thing is this implicit differentiation problem. Number one says, consider the curve. Okay, so this is the equation for the graph. Any point that I plug in, I can find the order pair. So it says find 2 points on the curve at x equals 0. So if I plug in 0 in for x, if I can solve for y, then I'm able to find those points. So the 0 cancels out the y. I'm just left with y squared equals 4. We take the square root of both sides. We get plus or minus. So we get y is equal to 2 and negative 2. And those we have our order pairs, right? We have 0, 2, and 0, negative 2. Normally this wouldn't happen on a function, but this is not a function, so it's okay that we have 2 points that are directly above each other. All right, any questions with number 1A? All right, for part B, it says differentiate implicitly. So we're gonna have to find the derivative, power rule, but then what do you guys notice here? We also need to use what? The other one, not quotient, product, right? Product rule. But product rule, we got careful though, there's a negative, so that negative has to distribute through. So there's a couple of things we got to watch out for here. Okay, so first things first, I'll take care of that x squared. I'm going to put a big parentheses as a reminder that I got to distribute that negative through when all is said and done, but I'll set up my f and g. Okay, so let's fill this in here. Okay, so what's f prime going to be? Just 1, okay. Times g y plus f, which is back to x. And what's g prime? 1, but we're good. Yeah, 1 because y's derivative is 1, but then we need to apply that dy dx. Yeah. Okay, keep going here. We have another term, y squared, that also needs to go through our derivative step. Y squared becomes
2y.
Mm-hmm. Is that it? What else do we need?
And then also dy.
Also dy dx. Yeah. Anytime we are asking for y's derivative, we got to attach that dy dx. Okay. Equals to 0. Good. Right. We don't want to forget. A lot of times we want to leave that constant there, thinking that it's not that we're not taking the derivative of that, but we are. Okay. So 4 will turn to 0. So that negative parentheses is helpful. Now I can distribute the negative through and then continue my cleanup steps. I'll leave the 2 dy dx terms on the left. I'm going to move the 2x and the y over to the right side. So now I can factor out dy dx because all my terms have dy dx in them. Okay. Divide the parentheses over. Okay. Any questions here? So our derivative equation is also our slope formula. Keep that in mind. And we can't just randomly cancel stuff out, right? Maybe some of you are thinking, okay, what if I cancel the x's out, the y's out, the 2's out, I'm just left with -1, okay? There's plus that's separating these terms. We can't start canceling out. Okay, this is as far as we can go. Okay, no questions? All right, part C. Find the slope of the tangents. So we're looking for slope. So dy dx is going to help us out here, right? So if I want to find the slope at my first point is 0, 2. And I'm going to plug this into my slope formula. So to indicate that I'm ready to plug something, especially order pairs, into my derivative, I put a vertical line. Yeah.
Will you get the slope formula from like the part B equation?
Exactly, yeah.
Okay, I just want to make sure.
Derivative formula, yeah.
Okay.
It looks different, right? Normally you're used to maybe seeing f prime being like 2x squared minus 4.
Yeah.
Right, but here we're dealing with a function, so that's why our derivative is always going to be in terms of x. So if where our equation is a little messier, our derivative is going to look a little more strange, but it does the same thing. They both give us a slope.
Okay, so then you just plug in 0 for x.
That's right,
Okay.
and 2 and for y.
Okay, thank you.
Okay, those of you on Teams, are you guys okay? Any questions? Okay, so we get 2 over 4, which is 1/2. So that's our slope, right? Our slope at 0, 2 is 1/2. So now we want to find the slope at the other point, which is at 0, -2. Same thing, plug into the derivative to get our slope. Also 1/2. So looks like both points are producing a slope of 1/2. All right, no questions, part C? All right, part D, write the equations of the line. So we have all the information that we need, right? Point and slope to do point slope form. So the first one I have is second one. Okay, are we doing okay? You guys okay? All right. All right, for part E, set up and write equations, but no need to solve. How to find vertical and horizontal tangents. So vertical tangents, we set the denominator of the derivative equal to 0. And the horizontal tangent, we set the numerator of the derivative equal to 0. Okay, so this is as far as we need to go for part E here.
So on the test, we won't actually have to solve this. Just set up.
Unless it is down to one variable. If it's only one variable, if it was, let's say it was negative 2x plus 4 is equal to 0, then I would ask you to solve.
Okay.
But if it's two variables, I would just ask you to set up. First page, everybody good? All right, let's go to the second page. So given that our function is differentiable and a and b are constants, find a and b. Okay, we have to involve derivatives in our work. If we have two graphs, right? These two graphs are supposed to connect at -2, but not only are they going to connect, they're going to have to connect in a way where there's a smooth transition from one graph to the next. So the slope must be the same as well. So we want these two graphs to share the same point, and then we also want these two graphs to share the same slope. So shares same point at x equals -2. And we also want them to share the same slope at x equals -2. So if they share the same point, that means the two graphs must have the same y value. So that means we can set the two graphs equal to each other. Replace all the x's with -2. Let's keep going here. We get -48 minus 32 plus 8. Use our calculator, combine that, we get -72. So we're at a point where we need some help, right? Because there's still too many variables. Maybe this second equation will help us out. But any questions up to this point? Okay, we also want them to share the same slope. That means we can set their derivatives equal to each other. So can somebody tell me what is the derivative of the first expression? Yeah, 18x squared minus 16x, and the constant goes away. Okay. Okay, somebody on Teams, can you tell me what the derivative of ax plus b is? Anybody on Teams want to chime in?
Is it just A?
Yes, it's just a. What happens to the b? Isn't b a variable? Shouldn't b go to 1?
Well, b is like a given constant, so it would disappear as if it were a normal standard number.
Good, right? So let's not make that confusion, right? Sometimes we want to look at that b and we don't think that's 1, but in this case, the statement is a and b are constant, so b goes away, ax becomes just a. Yeah. All right, so I want to make sure that we're good here because this is the calculus portion of our problem here. Okay, no questions? All right, let's plug -2 in for the x. So this one works out nicely because it just goes all the way down to a. Now, if there were a's and b's here, then we would have to go through substitution, plug in one in for the other and solve. But in this case, it looks like the a is going to work itself out nicely here. So 18 times 4 plus 32, I got a equals 104. And now I can use this to assist my other equation to solve for b. Let me put this over here. So I got b is equal to 136. All right, any questions there with number 2? Okay, number 3. We need to be able to look at the equation, decide which method is involved to find the derivative. And then once we find the derivative and then plug in the x value, we can go to the graph and either pick out order pairs or slope. Okay. So what rule do we have to involve here? Product rule. Okay, so let's build h prime first, and then I can plug in the 2. So f prime g plus f g prime. Okay, I'll replace every x I see with 2. So f prime of 2 is asking for the slope of the f graph at 2. G of 2 is asking for the y value of the graph at 2. So let's go to 2. F prime of 2, so what's the slope of the f graph at 2? What's the slope of this line? -1, right? Pick 2 points on this line, down 1 over 1, negative slope, -1. Okay, G of 2 is asking for the y value of the G graph, which is 2. F of 2 also shares the same y value. And now G prime of 2. What's the slope of the G graph at 2? What do you guys see there? Any idea? What do you guys see?
Would it just be 1?
It's this is going to be positive 1. Yeah, positive 1. See, this point is hard to do rise over 1. So I'm just going to pick another point on the line and do from here, right? Up 1 over 1, slope of 1. So I get -2 plus 2, which is 0. So my final answer is 0. Okay. On the test tomorrow, I'm looking for more than just your answer. I'm looking for your work that supports your answer. Okay. Part B. This is chain rule, right? It looks kind of similar because they both have f and g, but you see how these have x's in 2 places? So these are 2 separate functions. This only has 1 x, so it's a function within the function. So this is chain rule. So chain rule says outside's derivative times inside's derivative. So the outside portion is the f parentheses, and the inside portion is the g parentheses for g of x. So if I take turns with the derivatives here, my outside's derivative, f, is not something that we can do power rule. It's in function notation. So we say f prime of parentheses times the inside's derivative. So g of x becomes g prime. And then the first parentheses we keep as the same original inside. Okay, any questions with this setup? Okay, next step. Now we can involve the 3. Replace the 3 in for the x. So now we have something that looks a little complicated in terms of what to do, but maybe we can divide and conquer, right? Maybe we can work on a portion that is easier to do. So what's an easy place to start with this problem? Or easier place to start with this problem? Yeah, let's find g of 3, right? This is too complex, but maybe if I can figure out a portion of it, it'll make it easier to interpret. So I'm going to find g of 3. And that's the only thing I'm going to find. I don't want to do more than that because I want to see what that update will give me in terms of clarity. So g of 3 is asking for the y value of the g graph at 3. So what's g of 3 equal to? What's that y value? What's the y value here? It's between 2 and 3, right? So 2.5. So we'll replace g of 3 with 2.5, and then let's just see where that takes us. So now we're looking for the f graph slope at at 2.5. So 2.5 is over here on the f graph. What is the slope of this point? What's this? This is part of this line, right? So if I can find the slope of this line, then I know the slope at that point. What's the slope? -1, right? Down 1 over 1. Yeah. And what's the slope of the G graph at 3? Zero. Yeah, that's a horizontal line, right? Slope is 0. So -1 times 0, the answer is 0.
Just to clarify, 'cause I don't know. At f of 3, the slope would be undefined, right?
That is right. Yep. If I asked you for f prime of 3, you would say undefined.
Okay.
And if any portion of your problem is undefined, your entire answer will become undefined. So just to kind of extend that, where else do you see undefined slope?
G prime 2.5.
Yeah, 2.5. There's another sharp turn here, right? So slope 0, slope undefined, but everything else, they're all going to be slopes that exist. Okay, look at part C. What's involved here for part C, you think? It's chain rule again. But it looks a little bit different, right? Maybe let's gather outside, inside information and see if we can do something with that. So what's the outside portion? Cube, good. And the inside is just f of x. So this is a little bit different because before, the outside, inside were both function notation, so the best we can say is f prime and g prime. But now this is something that we can find the derivative of, right, using power rule. And when we get to the inside, then we do function notation. So sometimes there's a mixture between parts that are power rule and parts that are just function notation. But either way, it's chain rule, right? So we take turns with the outside followed by inside's derivative. Let's not worry about the 0 yet. Let's just figure out what z prime of x is. Okay, what's outside's derivative?
6 brackets f of x bracket squared.
Right? We take the outside's derivative, bring down 3, subtract 1 from the exponent, but we leave the inside alone. And now, in a separate location, we're going to put the inside's derivative. So f of x becomes well, let's look at the previous one, right? How did we handle this g of x? We just made it prime. Yeah, there we go. So one of them is one of them requires power rule. The other one is just function notation. But either way, we arrived at the derivative for both of them. So now we can replace the x with 0. Okay, so just like before, we want to start with the easier part, right? Let's work on that f of 0. So what's f of 0? Four, right? So we have 6 times 4 squared times, okay, what's f prime of 0? Close. -1, right? Down 1 over 1. The graph is falling from left to right. So 6 times 16, 96 times -1. Okay, for part D, what rule do we have to use here?
Nice chain.
Chain rule again. Yep, chain rule again. Okay, outside, inside. Outside is the f parentheses. Inside is the f of x. So we take turns with each of their derivatives. Outside's derivative, f prime of parentheses, times the inside's derivative, so times f prime. And then the inside stays unchanged. Okay, replace every x we see with 4. Now, just like before, right, let's start with the easier part. What's f of 4? 2, good. So let's see what progress we made here. So now we're down to 2 slopes that we can find, right? What's f prime of 2? -1. What's f prime of 4? +1. So we have our answer, right? -1 times +1 is -1. All right, any questions? All right, let's look at part E. What do we have to use here?
Quotient rule.
Yep, quotient rule. Now, there's something we got to be careful about. What do you notice that we have to be careful about with quotient rule here? That could be mixed up by students. You know how quotient rule, I normally say f prime g minus fg prime all over g squared. Can we use those exact notations in this problem? What's different? Yeah, so I mean, you still use the basic quotient rule, but you got to flip-flop all the letters, right? So normally it's the top's derivative times the bottom minus the top, bottom's derivative all over bottom squared.
Oh, so it would just be like g prime.
There we go. Yeah.
Minus g times f prime and then over f squared.
Yeah, that's right. So we can't just always, this rule is because I'm basing it off of the f being the top and the g being the bottom. But if the g and f are flip-flop, then we have to make sure we adjust for that change. So. Okay, we should be in the clear now, right? Replace every x with 1. and then pull all the slopes in order pairs. And let's see what you guys get. F of 1 and G of 1, I'm just looking for y values on the graph. G prime and F prime, I'm looking for the slope of my F and G graph at those points. I got 4/9. Okay. All right, any questions? Okay, next one. We have a problem here that also is chain rule. You have parentheses with messiness on the inside and exponents on the outside. So we're going to need to set up a couple of things here. First, there's the chain rule portion, but then look at the inside. There's also a quotient rule portion. So we'll do chain, and then within chain, we got to deal with quotient. So outside portion first is the 2 parentheses to the 7th. And then the inside portion so what's outside's derivative here? To the 6th, right? Bring the 7 down, subtract 1 from the 7. And now when we are ready to do the inside, you see that this is set up requiring quotient rule. Okay. The original, for the first set of space, is going to be the original inside. Now we move into quotient rule. Okay. What's F prime going to be?
15 squared.
Yeah, 15x squared. G function, no changes. Back to F. And then G prime, what's G prime?
-2x.
All over denominator squared. Oops, sorry, 3. All right, so this is the answer. You've earned most of your points here, but it's asking for simplified rational expressions. So let's get it down to 1 fraction. Careful how you reduce, though, right? We can't do this. This is tempting, I know, but we can't just take these 3 minus x squared out. So I'm going to expand this out. I'll put this above to give myself more room. So if I distribute this through here, I get I think it's easier if I just put the negative 2x in front and then just multiply the negative times negative 2x, which is positive 2x. And I'll just distribute the positive 2x through. But you can choose to expand however way you want. Okay. Now let's put it all under one fraction. So let's see what belongs up top and what we can put below. So above, I see the 14. I see the 5x cubed minus 2 to the 6th. And then if I continue to clean this up, I get negative 5x to the 4th plus 45x squared minus 4x. Doesn't matter which order you put those in. All over my denominator. So how many 3 minus x squared are we dealing with here? Good. I know it's easy to look at this and think that maybe it's just 3, right? There's 1 here and there's 2 here. But what's easy to miss? Yeah, this 6, gotta pay attention to this, is 6. That 6, it affects the numerator. I think we all see that, but sometimes we forget that the 6 is also seeing the denominator. So there's 6 of these, and there's 2 of them here. So 6 plus 2 is going to be 8. Okay, question, second page.
For the final portion problem, why is it negative 5x to the 4th and not 15x to the 4th?
It was negative 15x to the 4th. I just combined these two terms together. Like terms. Right, because from here, I got to here, and then from here, I got to here. Does that make sense?
Yes, thank you.
Okay. All right, third page. We have our particle position function. Let's find our velocity and acceleration. So power rule will get us to those places. Keep going, acceleration. Find when the particle changes direction. So this is a multi-step process, right? We first have to figure out when the velocity is 0. Solve for t, create our sign line, test the intervals. So the first thing we do is find first when v of t is equal to 0. Because we need to create some boundaries for intervals so that we can have intervals left and intervals right. Okay, so I set my velocity equals 0. I'm going to take a GCF out and continue factoring. factor of t. Multiplies to be -4, adds it to be -3. Solve for t. We have 3 t's, so we should get 3 solutions. Okay. We have negative numbers as well. Are we going to keep the -1 here? Or how do we make that decision? Whether we keep negative numbers or not?
It says it's greater than or equal to 0.
Yeah, but in this case, it tells us what?
It's just,
Well, it says for all real numbers, right? Yeah, so this means that we're going to include negatives as well. Okay, so here's my velocity sign line. Okay, we'll test all these intervals here. So I'll test with -2 here. I'll test with -1/2 here. I'll test with 1. I'll test with 5. I like to put it into the factored form. It gives me quickest access to the sign. So negative times negative times negative is negative. -1/2 will give me negative, negative, positive. So 2 negatives is just a positive. Plug 1 in, positive, negative, positive. Plug 5 in, 3 positives. So we can say direction change at -1, 0, and 4 because velocity changes signs. Okay, part C. Determine intervals when moving left and intervals moving right for D and justify with answers. Okay, moves right. All right, so take a look. Any questions here? No? Okay, for part E, find average velocity. So how do we interpret average velocity? Right, change in position over change in time. We don't touch velocity. I think that's the hard part to get over here. We don't touch velocity. It's the change in position over change in time. We have our endpoints. So we'll do x of 3 minus x of 1 over 3 minus 1. Use our calculator to figure out our positions at 1 and 3 seconds. Negative 22 over 2, which is negative 11. And what's our unit of measure? Meters per minute. Okay. Any questions here? Okay. So we take a similar approach with how we tackle average acceleration. What do you think the definition for average acceleration is? Change in velocity over change in time. Again, with acceleration, average acceleration, we don't touch acceleration even though it's in the name, right? So we'll find V of 3. We'll find V of 1. Which is negative 12, 6. So I get negative 6 over 2, which is negative 3. And what's our unit of measure? Yeah. Good. Find the particle's displacement. So our formula for displacement is final position minus initial position. So x of 6 minus x of 1. So we can find the positions at 6 and 1 by going back to our original position function. So we get 37 minus negative 1.74. Okay, so those are what I found by plugging the calculator. Remember, displacement could be negative, right? If you get a negative answer, then you leave it there. That just means that you ended up further left than where you started. But so it could be positive or negative. All right, find the particle's distance. So to find distance, we need to make sure that we include any places where there's a direction change. So do you see any direction change between 1 and 6? Yeah, 4. So even though distance we don't involve velocity, but we kind of do because we kind of need the velocity sign line to kind of help us decide where there's a change in direction. So that means we need to find the position at 1, we need to find the position at 4, and we need to find the position at 6. Okay, we have 1 and 6, right? We found those from the previous parts. We just have to plug in 4 into the position function, and I get negative 31. So we have to figure out how far am I going to travel to get from here to here, and then separately I need to figure out how far I travel to get from here to here, and then add these two distances up. So I figured maybe it's easiest if we just kind of visualize it. Imagine these are numbers on the sign line and you're trying to get from one location to the next. So you're starting at negative 1.75. And you're going all the way left to negative 31. And then you're moving all the way right to 37. So you want to find out how much distance did you cover. So we're starting here, and we're going all the way to negative 31. And then from here, we're going all the way over to 37. So we can just subtract these values and then just make sure that we inherit the positive value of that. So negative 1.75 minus a negative 31 will give us 29.25. And then 37 minus a negative 31, that distance is going to be 68. So despite the fact that we're moving left, we're going to keep that as a positive number. So both are positive. We add those together, total distance. Questions? Okay, 2 more. At t equals 2, is the speed increasing or decreasing? How do we determine increasing and decreasing speed?
By determining the difference or direction, the same like the signs that they have.
Yeah, and if they have this, if they have the same signs, what does that tell us?
If they have the same signs, then it's increasing.
Yeah.
If they have different signs, it's decreasing.
Right. We compare signs between velocity and acceleration. So let's find the velocity at 2. So we plug 2 into the velocity function. We'll get negative 12. We plug 2 into the acceleration function. We get negative 4. So double check my work. Is that what you guys got? Okay, so they're both negative, right? Same signs. So we know speed is increasing. Okay, for J, is the velocity increasing or decreasing? How do we interpret that?
For velocity, if it's positive, it's increasing. If it's negative, it's decreasing.
That, yeah, be careful though. What do we look at?
Uh,
Do we look at velocity?
oh, no. The acceleration.
Yeah, gotta look at acceleration. I know it's tempting to look at velocity because the word is right there, but that increase, decrease, it changes definition, right? This is no longer velocity. It's now talking about the rate of change of velocity. So this is describing So we look only at acceleration, and that's it. So acceleration at A of 5 is 41. So I have a positive acceleration, which means my velocity is increasing. All right, any questions? All right, I'll stick around in Teams if you have any questions, but otherwise I will see you tomorrow, 7:15. I'll do another review, but I'll pick the morning review worksheet 3. But I think this is the best gauge as to what to expect on the test tomorrow.
Thank you very much.
All right, thanks guys. I'll see you tomorrow.
See you tomorrow. Thank
Take
you.
care.